Hey there, math fans. Going to talk about topic 2 as you prepare for exam 1. I wanted to have a video where I somehow talked about speed, distance, and time because that is a major topic. So in case you've forgotten, distance is speed times time. We've used that a lot. We've used it in sort of all its different forms. We sometimes have to compute the speed by doing distance over time. We often have to compute the time by doing distance over speed. We've played that game a lot. So I wanted to talk about that, and I thought, well, if I'm going to talk about it, I should also talk about uniform linear motion because those problems also always have time involved. Now, uniform linear motion we only spoke about in a tiny bit, and so this hopefully also will deal with that. But my main focus is I wanted to remind you of a few things about how this pops up. Okay, I've got my calculator ready. Let's go. So these are from my, from the practice page I gave. There's more examples listed in there, and you can click on the exam archive, click on solutions. Okay, so the moment you see uniform linear motion, you are filling in the following. So let's sort of review quickly, just so I can get through this. No one's listening anyways. So I need a starting location, and I need what I labeled as the horizontal velocity, change in x, over the time it takes. And again, we're not doing like a full general study. The idea of this was to give you a little bit of a taste of parametric equations. So when you go into calculus, it's not your first time ever seeing it. Okay, so our job is to fill those things in. We need a starting location, an ending location, and the time it takes. And I have a little animation going of this problem in the corner. Okay, so what did they tell us? They told us a starting location. They said Peyton starts at the point -2, 11. So you can see we already have some of the stuff we need. -2, 11. Then what did it say? He ends at the point 5, -13. So we know that as well. 5, -13. So all that's left to figure out is the time it takes, but they didn't give it. What did they give? They gave his speed. So this is why I really picked these problems, is I was like, oh, time is distance over speed, and they told me the speed is 4. So really what I needed to do to figure out this time was to figure out the distance. So like many problems, you have a little additional problem here, which is how far is it between these points. So 5 minus -2 squared plus, try to keep my order the same. And I computed this already, and it turns out, actually I don't remember what it was. 7 squared plus 24 squared, square root of second. Oh, it's 25. So 25 over 4 is my time, or 6.25 seconds. And that allows you to finish the problem. Maybe I'll just write it up without even doing all the calculations. You say this is -2 plus, I think I want it, 7 over 6.25, 1.12. And then y is -24 over 6.25, -3.84. That's it. So the added little piece here was having to remember this fact. Beyond that, we were just plugging in. So we plugged in this 6.25. So even if you're like, oh, we only did a couple of problems like that, that's true. There were only a couple in the homework. It's mostly, did you have that on your note sheet? The other question actually could have been done without this, but let's look. So Eli starts at 10:07. And runs to the place where Peyton crosses the y-axis. So let's grab my animation now just for a second. Stop moving. Let's graph this line. We would like to know where that y-intercept is. You could find the y-intercept by just finding the equation of the line and finding the intersection. In my solutions, you'll actually see I did that. I gave alternate solutions. So again, you could do all of this from that. And at that point, you'll know everything you need to know. But I'm going to try to do the problem directly. So if I want to know when Peyton crosses the y-axis, where would I be? So when he crosses the y-axis, he'll be here, which means his x will be 0. So you can actually work with this directly. I'm saying this is 0. And if that's 0, I can solve for t. So I can do add 2 to both sides, divide by 1.12. I think it's not a nice number yet. Not a nice number. I get t is... So this is a chance to... Really what we're doing now is making sure we understand the coordinate system. What does it mean to be on there? Once I know the t, I can plug it into either one, but in particular that one, 11 minus 3.84 times second answer, enter, 4, so I get the y is 4.142857. So now I have this point, 4.142857. And if you think about what the question's asking, it's saying, how fast does Eli need to run? If he's running from the points 10, 7, somewhere over here, to this point. Well, we know everything we need. So now it's a question of finding speed. How do we find speed? It's distance over time. So you'd find the distance between your Eli's 2 points, 10, 7, and this point we just found. So 10 squared plus 7 minus this messy number squared divided by the time it took. That's it. You get like 5 point something seconds. You're done. Just because I made the animation, let's let it run for a second. So here we go. Let's throw Eli into the mix. Eli's going to run towards the same point. He's going to follow this line. I mean, not that line. This line. Let's send him back to the start. And let's let him go. So here we go. Let's see if we've done it. Boom. Okay, on to the next one. So then I just found some other old exams that had this. This is the same idea. In fact, this first part is even faster than the one we did before because they tell you the time outright. So let's just do another one so that people can feel more confident. Starting at the point 7.2, ending at the point -3.3. So let's start to fill in the numbers. Velocity in the y direction. Change in x. Change in y. Start ending at -3x, ending at -3y, dividing by 8 seconds. This gives me -10/8. Oh, I should have simplified. -5/8. Done. It's that fast. Victory, I guess. I don't know how you say that. Victoire starts at the point -5.6 and walks on a straight line to the point where Robin crosses the x-axis. Oh, crossing the x-axis. So maybe like here. Well, that would mean y is 0. So we're going to do that is 0. We're going to find the time. We have the speed. So there we go. I mean, in this one, you know where they're starting. -5, 6. T. What does it say how long? Crosses at a constant speed of 2 units per second. Oh, so we're going to need the time it took her to get there, knowing that she went from -5.6 to this point we'll have just found in the previous part, and knowing that she's going 2 units per second. So you'll have to do time is distance over speed. Okay. So I'm going to leave that. You can check the solutions for more details. One more, just so I can kind of get the pieces flowing here. There's a bicycle. There's a fountain. The bicycle starts from a point 33 units east and goes towards a point that's 56 meters north. So this is like the starting place, going 13 meters per second. So we're starting at 33.0. And we need to figure out the horizontal velocity. So we ended at 0 for x. We started at 33, but I don't know the time. Vy, so we ended at 56, we started at 0. How in the world do I get the time it took to go from here to here? Ah, there we are again. Time is distance over speed. So we need to compute the distance between those 2 points, divide by speed. That'll tell us our time. We can fill everything in. Okay, I think I'll leave those. I just wanted to get you to see a couple of those problems. The bigger thing is, don't forget, you probably are going to have to end or start a problem somewhere with time as distance over speed. So just, if you see it, just say, okay, I'm not worried about that. I just start computing the distance. Yeah, it's kind of messy, but don't let that stop you from doing it. Expect it to happen, that at some point you'll have to do the distance between a couple points. Okay, hope that helps.